Hello, Mahendra. Before we start, please tell me the name of the subject of the SNAP and the company for which you are preparing.
Sir, the subject will be mass transfer operations, and the college is NITIE Mumbai.
Okay, you are preparing for NITIE Bombay. Okay,
Yes,
tell
sir.
me what is fixed law of diffusion?
Sir, fixed law of diffusion states that the molar flux will be directly proportional to the negative of concentration gradient,
Okay,
and the equation is J equals to minus diffusivity into concentration gradient.
okay. How many types of diffusion you know?
Sir, I know two diffusion. One is molecular diffusion, and other is convective diffusion.
Okay, what is convective diffusion?
Sir, in convective diffusion, the transportation of molecules will be happening because of the bulk movement of the molecules.
Okay, and what about diffusion? There is no bulk movement of molecules in diffusion.
Sir, it will be primarily because of the random movements of the molecules due to the concentration gradient.
Okay, and there is no concentration gradient in the convective diffusion.
So there may be the concentration gradient, but the diffusion will be the transport will be happening because of the blowing wind, or any other flowing fluid which is moving. Any external impetus is there.
Okay, any kind of diffusion?
What's it?
Any other kind of diffusion?
Sir, I have also read about the Knudsen diffusion, which is happening between the solid and fluid, and it is basically because of the pores.
Okay. Hmm. What is the difference between molecular diffusion and eddy diffusion?
Molecular diffusion and eddy diffusion. Sir, eddy diffusion, if I remember correctly, it is also based upon the bulk movement of molecules because of the eddies which are being created.
Okay.
While molecular diffusion is the same because of movement of molecules due to gradient.
Okay. Okay. Tell me Fields theory. What is field theory?
Sir, in films theory, we suppose between two, if there are two gases or gas or liquid, then there will be a film interface forming in between them, and there will be no resistance in this interface, but there will be two films forming on the left and the right side of the interface. All the resistance will lie in that film only, and that will determine the rate of the mass transfer.
Okay. Okay. What is turn-down ratio?
Turn down ratio. Sir, is it the is it related to distillation columns?
Yes.
Uh, Sir, is it like the maximum amount of vapor flow divided by the minimum amount of vapor flow which we could achieve in a column?
Okay. That is one type of turn-down ratio for a particular tray.
Sir, I only
What
know
about
this much.
the unit throughput? We also say unit throughput in terms of turn-down ratio.
Unit, I think in our plant, turn down ratio is also defined as like the maximum throughput a unit can have divided by the minimum throughput a unit can have.
Okay. So what is the turn-down of your plant?
So turn down of my plant will be 205 divided by 130, around 1.7, 1.6. The maximum charge of our unit is around 205 and minimum is 130.
Okay. So you are sure it is 1.7. Shutdown ratio is basically denoted in terms of percentage.
Okay, so then I am not aware about it. It is denoted in terms of percentage.
Okay, no problem. Okay,
Sir,
what are
is it
the
like
basic?
the charge, like if
Okay,
I
tell
am
me, tell me.
running, if my maximum design charge of my unit is 210, and if I'm running that unit on 210 charge for whole month, then turn down for my unit will be 100%.
Okay. What will happen if you operate below the minimum throughput?
Sir, I think a unit is designed for some minimum charge. Otherwise, the efficiency and other calculations will be disturbed because there will be heat exchangers and other absorption or extraction happening along the way. And that can only happen at some particular range of flow rates of liquids and vapors. If that is not there, that means the whole equilibrium of the system will be disturbed, and the product quality which we won't be getting.
Okay. Okay. What is extraction?
Sir, extraction means we are extracting some component. It is basically liquid absorption. One solvent will be extracting solute from the other liquid because of the because that has more affinity towards that solute.
Okay. So can you give me one example of extraction in your plant?
Extraction in my plant.
Any industrial
Sir,
application use case.
yes, yes. So right now I can't remember extraction example. I know
You are working in
absorption.
Jamnagar refinery, right?
No, sir. A Kochi refinery BPCL.
Okay. So there is no application of extraction there.
So in my plant actually there is absorption happening, but extraction it is not there.
Entire plant of Kochi refinery, no extraction.
Entire plant, if I have to say, sir, I don't have much knowledge about the other units, so I can't comment on
Okay.
that.
Okay. Tell me about the absorption. Give me one example of absorption.
Absorption. So, like if we have gases which has components between C1 to C4, and if we have liquid which is very heavy like petrol, so basically we are using that petrol to extract some valuable components out of that gases which has component from C1 to C4. So C3 and C4, some amount of that gases will be absorbed in the petrol. So uh, so a lot of gas won't be released as the fuel gas, which is a waste to the refinery.
Okay. So how absorption phenomena is taking place here? This is, I'm thinking, this will be like distillation, just normal distillation you are saying, right?
So one one is the packed bed column and other is having trays. There are two columns basically.
Okay. So what is the solvent here?
So the solvent will be the petrol, and the solute will be the C3 and C4 components which are present in the gas.
Okay.
It is basically designed for 95% of absorption of C3 and C4s.
Which gas?
So propane and butane. Gas means it will have mixture of C1 to C4. So
C1 to
basically, we
C4.
want
So when you are
uh,
including FG to LPG, right?
uh, fuel gas. Basically, we are releasing, and this C3 and C4 we are adding in gasoline, so that after this column we can heat that and extract LPG above and gasoline below.
Okay. Okay. Hmm. What are the basic characteristic of a mass transfer equipment?
So characteristics, I didn't get that. Like characteristics means
What should be the common traits should be there for a mass transfer equipment?
traits.
If you select one mass transfer equipment, so
Okay.
what should be the minimum criteria that you will consider while designing a mass transfer equipment?
Okay. So suppose like this absorption column, if we are designing
Okay.
that, I know that it will be handling gas somewhere between 20 to 30 tons and liquid that would be somewhere between 100 to 150 tons. So my equipment trays should be able to hold up that amount of liquid or gas, and the efficiency should also be there. There should be a minimum number of trays which should be there to achieve that level of purity,
Okay.
and the uh, diameter of the
Hmm.
column should be enough to accommodate that much gas flow rate.
Okay. Anything else?
And so there is also one more thing that while absorbing, the temperature of the liquid may increase. So we may have to use some exchangers between that column. So that also we have to consider the heat of absorption. These thing I can, and the pressure of the vessel should be such that it can accommodate 20 tons of gas, around 10 to 15 kg per centimeter square of pressure.
Okay. Okay. Tell me what is Murphy tray efficiency?
Sir, Murphy tray efficiency would give us an idea about, like, there will be some constant, like vapor will get liquid vapor will get somewhat absorbed in the liquid, and like it will consider an equilibrium ideal case in which the change of concentration will be measured against what is the actual scenario of change in concentration. So actual change in concentration of the vapor divided by the ideal change in concentration of the vapor. That is the equilibrium.
Okay. So what do you mean by ideal change in concentration?
Uh, that means our there will be one equilibrium point. Like beyond that percentage, the solute won't be absorbed in the liquid. So Murphy tray will consider that as the maximum possible efficiency which a tray can have, that it has diluted the vapor till the equilibrium state.
Okay. So how do you define a state as an equilibrium or ideal state?
Sir, that would depend upon our equilibrium line. Like beyond that, there will be no absorption.
Okay. Okay. Now I am giving you the feedback.
Okay.
Okay. About Murphy efficiency, it tells about this is the ratio of actual separation divided by theoretical separation. Okay.
Yes.
And you said it correctly.
But
So,
I was not able to explain in
huh,
short.
what is
Yeah.
ideal? What is ideal stage? Basically, in ideal stage, when do we say that two streams are equilibrium?
Hmm.
The living stream of vapor phase and the living stream of liquid phase. Okay,
Correct.
they must be in equilibrium. Then the
Correct.
stage is ideal. Okay,
Idea.
this is the thing you are missing in the
Huh.
statement.
Correct.
Rest, all those things you have said correctly. Okay.
Oops.
Then mass transfer equipment. What are the uh, uh, basic attributes of mass transfer equipment? Uh, some points you have said correctly. Okay. So
Hmm.
it should have large interfacial area so that we can enhance the mass transfer.
Correct. Hmm.
Okay. Uh, it should provide a high degree of turbulence for the same reason. Okay.
Correct.
Delta P should be low.
Hmm.
Liquid hold up. should be as per the requirement or low liquid
Mm.
holder. Ease of separation of the phases should be separated easily,
Mm.
and ease of maintenance, and it should be cost effective.
Mm.
Okay, there is
Okay.
no if it is not cost effective, then there is no point of designing that mass transfer
Correct.
equipment.
Mm.
Okay, and as far as the turn down ratio goes, generally it is the turn down ratio of a unit or a plant is defined as like minimum throughput divided by maximum throughput as per the design.
Mm. Okay.
Okay. And as far as the turn-down ratio of that particular tray concerned, it is maximum throughput divided by minimum throughput. Okay,
Okay.
for a particular tray.
Okay.
So this is all about turn-down ratio. Then one more thing I have asked. Diffusion, types of diffusion. There are various types of diffusion are there, like
Mm.
molecular diffusion due to the collision or molecular transfer of
Mm.
the molecules. Eddy
Mm.
diffusion. Eddy diffusion happens. How eddy diffusion happens? Due to the presence of eddy currents or circulating
Ah.
currents.
Mm.
Okay, you said it correctly that it is like convective diffusion, but convective is basically associated with bulk motion of
Bulk.
fluid, not it is associated with the
Mm.
molecules. Okay,
Ah.
generally with molecules we don't associate these terms convective. Convective is always
Mm.
associated with bulk motion. Okay.
Okay.
So as you said that the bulk motion of molecules. So molecules will be in motion if it is diffused. Okay. So if the diffusion is happening in a certain pattern, like eddy currents is there or circulating currents is there, then it will
Mm.
be eddy diffusion. Okay. The
Okay.
diffusion rate will be faster. That is the only difference.
Yes.
Then molecular diffusion, eddy diffusion, thermal diffusion, Knudsen diffusion, pressure diffusion,
Mm.
force diffusion. These are the various kind of diffusion
Okay.
based on its gradients. Okay.
Mm.
Anything else?
Sir, I have one doubt regarding that diffusivity and mass transfer coefficient. I'm not able to get the difference between these two.
Okay. The difference is same as thermal conductivity and heat transfer coefficient.
Mm.
How they do
That
both
also,
are
that
how
also
both
I
are
was not
different.
able to answer
Okay.
you yesterday.
Okay. So as I have said before that one phenomena is due to the molecular. One is molecular phenomena and second one is macroscopic phenomena. Okay.
Okay.
The molecular diffusion or the uh, conduction, both are the phenomena is microscopic.
Mm.
We consider in terms of a molecular level. Okay, whether molecules
Mm.
is vibrating or not, whether molecules are
Okay.
the free electron is moving or not. Whereas this convection part, convection or the convective mass transfer are bulk motion. Okay,
Bulk motion.
so
Okay.
so K is mass transfer coefficient, whereas that DAB is diffusivity. It is only associated with diffusion,
Diffusion.
whereas K it includes both the diffusion part and the
Mm.
convection. So uh, to define the both mass transfer phenomena, we are using one
Okay.
terms that is mass transfer coefficient. Okay,
Okay.
Like your HA delta T, here also K into that is
Okay.
concentration difference.
Mm.
Got it?
Okay. 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 Yes, sir.